Good afternoon. The purpose of this lecture is to show the beginnings of the refinement stage when it comes to developing parts within Inventor. On the screen, as you can see, is the roadmap for parts creation. This is the common process and the common flow for creation of parts in Inventor and actually in any other 3D modeling software. We go from sketch, which is we try to keep it as simple as possible, which is 2D. We then convert that to the base feature, which is our first 3D feature. For lack of a better term, the material that we're going to be using as our starting point to create the part itself. We are now entering into the refinement stage. The refinement stage is a repetitive set of steps that we add additional features, and there are three primary types of features that we add in the refinement stage. And that is we can create sketched features, placed features, work features. We will be doing a demonstration on each one. For this particular video, we will be concentrating on sketched features. In upcoming videos, we will be looking at placed features and also the concept of work features. After we've created our refinements, this is where our part or our final part is then created. And as shown right below it, also do not forget to include or assign the correct materials for the particular part. So with that said, let's enter Inventor and let's see what we need to do. Alright, we are now in Inventor. We're in the sketch mode, and what we're going to do is we're going to create our base feature, and then from our base feature we're going to use a sketched feature to refine it to a specific set. Our first step is to create our sketch, and our first sketch I'm going to use something a little bit more interesting than just a simple rectangle. I'll use a center slot. I'm going to start the center slot at the absolute 0, drag out, and I'm going to give it a half-sized dimension. So I want this to be a total of 70 millimeters in length from center to center of the slot. So I will give it a 35 millimeter to indicate the halfway point. Hit enter. I'm going to drag, and then what I'm going to do is I'm also going to indicate how big for the overall width of this particular sketch, I'm going to indicate 25. Hit enter. Hit escape. Now I have my sketch. And as you notice right down here on the bottom, it is fully constrained, so I have no other dimensions or relationships that I need to add. I'm going to finish my sketch, and I'm going to give it an extruded length. I'll keep the default of 10 millimeters. So here's my base feature. From my base feature, now I'm going to start refining it. And the refinement purpose, the refinement process is going to be, I am going to create two individual bosses on both ends. They will be identical to the diameter of the outside edges. And then on the inside, I'm going to extrude cut to remove half of what the total width is. So with that said, I'm just going to go and click on my start sketch. And sketch features, we have to select a surface. So we're going to select this surface. So I'm going to select this surface, and it will place it in my normal. I'm going to use this particular tool. This is my project geometry. Project geometry allows me then to select edges or the entire surface, and from there it will allow me then to create a boundary. I need the entire surface to be actually etched or the edges copied. So what I'm going to do is I'm going to take my cursor and I will just simply click anywhere in the center of the surface, and then when I hit escape, as you can see, the yellow line is the outline of the surface. Okay, it's looking good. Next step, I'm going to create two circles. I'm going to create a circle using the circle command. I'll create that circle, and then I will create another circle from the center here, but I'm going to deliberately make this oversized. Okay, hit escape or right mouse button, check mark OK. So now what I want to do is I want to make this circle ensure that it is tangential to this edge. I will go upstairs to my geometric constraints, and with the geometric constraints, just will take a couple of seconds. Starting from the very top line, we have coincidental constraint, we have collinear constraint, we have concentric constraint, we have fixed, which would be the equivalent of nailing the geometry in place and not having it move. We have parallel constraint, we have perpendicular constraint, we have force horizontal, and we also have force vertical. We have tangential. We also have what is known as smooth. Smooth allows us to take two curves or two splines and then connect them seamlessly from one point to the other. It creates a very nice connection. We will be seeing that in upcoming videos. We have symmetrical, or the symmetry constraint. 3 objects are required in order to create the symmetry, as shown by the illustration right there. And then last but not least, equality. When we click 2 or more objects, we can make them all equal in size. So in our particular instance here, we're going to use tangential. So we're going to click, it doesn't matter which one you pick first. I'll pick the circle first, and then I'll pick the edge I want to be tangent to, and it does exactly what it's supposed to do. I'll do the exact same thing here, and this time I'm going to pick the edge, and then I'll pick the circle, and it'll still do what it's supposed to do. I'm going to finish my sketch. Now I'm going to take extrude, and if we take a look, the number of closed loops, which is what we're looking for to create solid features, consists of the following. If we select that circle, that is one closed loop. If we select this circle, that is another closed loop. If we hover in between, we have that closed loop, and we also have in total 1, 2, 3 separate closed loops. For me, what I want is this one. I'm going to select this closed loop. I only want this to be 10 millimeters to only be 5 millimeters. So I type in 5, and I want it to cut. So I'm going to change from, in my Boolean operation, I'm going to change from join to cut. And I'm also going to ensure that the arrow, as we can see right here, is pointing into the material as opposed to outside the material. So I'm going to click my vector, change it, and flip it to inside the material. And then all I need to do is just click OK. And now I have my first sketched feature. Okay. I'm going to add an additional sketched feature. The next sketch feature is that I would like to create a cutout. And the cutout is going to be made by using the edges of this portion to allow me to cut through that particular piece. So once again, I'm going to create a sketch. It's another sketched feature. This time I'm going to do the following. I'm going to go right mouse button. Rather than going up into the panels, if I go right mouse button, I'm also able to click on new sketch. So I'm going to click on that surface. Okay, it is once again normal to the screen. I'm going to use my project geometry. Once again, I want to project the entire surface, so I'm going to pick anywhere in here. I'm just going to click the little house symbol on my view cube, and my first additional tip is that if you hit F7, or if you go right mouse button, and actually I have to cancel the project geometry, that's fine. If I go right mouse button, and it's about a quarter of the way down, slice graphics, on the pull down, or the fly out, sorry, right next to it, it shows F7. So F7, if you hit F7, it will do the same thing that the Slice Graphics does. Now, what does Slice Graphic do? When I click on Slice Graphics, it removes temporarily the foreground, so I can actually see on the sketch plane what I'm actually working with. So it's a nice little tool to remember. And in fact, if you can toggle it, because if I hit my F7 now, it'll bring it back. If I hit F7 once again, it'll take it away. Let's take a look at it straight on. Okay. I'm going to use another tool. So I'm going to go to Modify. I'm going to click on Offset. I'm going to select the yellow traced line and then just left click once. And then I'm going to just drag inwards, and I'll drag inwards to a total of 2.5 millimeters. Okay, so 2.5 millimeters. I'm going to hit Escape. Now I'm going to get rid of some of the geometry here that I don't need by just simply going Trim. So I'm going to trim that portion off, this portion off, this. And I'm just going to go around and just get rid of everything that I don't need. So you can see. Now I can also hold down the left mouse button, drag right across, and it will do the exact same thing, just like so. Perfect. Okay. Now the relationship, because I've done that, has now been destroyed because I've cut the geometry. So I'm going to do the following. I'm going to click this edge and click this edge. Okay, so that is fine. But I also want to make this edge and this edge the same thing. So that's still going to be fine, but I don't want two competing dimensions. I want a parent-child relationship. So while this is still activated, I'm going to take my cursor and just click this number. What it's going to do is it's going to replace the 2.5 independent and place a D number. That D number indicates the variable's name. What that does is that if I click OK, or the check mark, right in front of the 2.5, an FX appears. That FX means that it is dependent on something. In this case, it's dependent on this one. Now, what exactly does this mean? If I click on this dimension and change this to, say, 3.5, hit Enter, what ends up happening here is that this moves as well as this. Now, I also want to make sure that these are concentric with this, so I'm going to click on my concentric, select, and select. It tells me that it is. I'll do the same thing, select and select. This is concentric, and that is concentric. Okay, so now these two are concentric to each other, but as you can see, they also can get larger or smaller. I don't want that. I actually want it to maintain a 3.5 distance. So it's a pretty simple matter. Just put in another couple of dimensions. Pick here and pick here. Now I have that, and I'm going to match it up with this again, just like that. And I'm going to do the same thing here and here, and I'll match it up with this again. So now this is perfectly centered. So what this means is that if I change this to, say, 1.5, everything automatically changes as it's required. So the term is parametric link. So I've created a parametric link. The parametric link means that this dimension will drive all of the other dimensions to ensure that it's not only centered, but it also follows the size. Let's finish our sketch, and we're going to do another extrusion. We're going to pick right in the middle. Once again, I'm going to use a cut, and then I'm going to just simply click OK. So now I have this part. I can continue developing it. I can add additional features, but it gives you a good idea of how that works. Now, for this particular part, we've just primarily used extrusions. We're going to take a look at by adding by using a revolve. So with that, I'm going to go New, and I'm going to start a new part again. Okay, and this time I'm going to do the following. I actually like slots. It seems to be working really well for me. So I'm going to have a slot that starts from here. I'll make sure it's nice and vertical, and then like that. Okay, so I'm going to create a dimension here. I'll make it 15. Its length, let's make it 36. The distance, what I'd like to have is between here and here. I'm going to have it as 10. I'm going to create one more dimension, or actually one more object, and that's this line right here. So in the slot, let's do this. I'm going to create a rectangle. Okay. Now the rectangle is purposely outside of the slot. I'm going to grab this edge and I'm just going to pull it inwards, and I'll do the same thing here. What I want to do is I want to make this slot, this rectangle centered to this line. So I'm going to now use another geometric constraint, which is up here. And I'm going to use our trusty coincidental constraint. Now, why would I use that? Well, I'm going to do the following. I'm going to select the center of the rectangle and match it up to the center of the slot. So what ends up happening here is that it not only attaches the rectangle to the slot, but it also imparts a symmetrical relationship to it. Okay? Add a few more dimensions. I'm going to add this. I will make this 26, and I'm going to make this, say, 6. Okay. So I'm going to finish my sketch, and I'm going to do a revolve this time as opposed to an extrude. So I'm going to select revolve, and once again, how many profiles or closed loops do we have? We have one full closed loop, we have a middle closed loop, and we have a third closed loop. So here are in total 3 closed loops. Well, the loop that I want is the overall. So I'm going to pick the edge, I'm going to select. Next, I'm going to go select axes. I'm going to select the line that I created, and it creates this feature. So I can rotate around. So that slot, when it's revolved, creates this really interesting looking spool. Alright, so we're not done yet. Why? Because the sketch that created this also had the rectangle. That rectangle we haven't used yet. So how are we going to use it? Well, if we go to the history tree, here's the first revolve. I'm going to click the plus sign, and then I'm going to click on sketch number 1. Now when I click on sketch number 1, as you can see, it shows what the sketch is, and it also shows that the rectangle hasn't been consumed. So I need to have some way to use it. I can retrace it if need be. However, if I put my cursor over the sketch and then go right mouse button, about a quarter of the way down there's something called Share Sketch. Okay, what Share Sketch does is that it brings the sketch back to the surface and allows me to then utilize any geometry that hasn't been consumed. So I'm just going to click on Share Sketch. There's my sketch again. And I'm going to do the following. Once again, it's going to be a revolve, but this time I'm going to pick inside the rectangle. So I'm going to pick inside the rectangle. I'm going to click the axes again, and I'll pick the black axes right there. And this time I want to have this as a cut. So I'm going to click on Cut, and then click OK. And now I have that shape. So it's now cut into that particular spool. Now, all of the dimensions are still exposed. This is very convenient because what this will allow me to do then is to do a few changes. For example, let's say 26. I don't like 26. I actually want 14. So I'm going to type in 14. I have that. Now, nothing's happened to it. The reason being is that I have to go upstairs to my update, which is right here, to do a local update. So when I hit that update, it adjusts. Let's make another change. Let's make the opening of the rectangle a little bit bigger. So we'll make it, say, 8.5. There we go. Once again, local update. There we go. Let's make the overall, the slot itself, let's make it, let us make it, say, 19. There's 19. Local update. Now it adjusts. So the part itself is fully controlled primarily through the fact that if we control the sketch, we actually are controlling the part. Okay? So to recap what we've done, and in fact what I'll do is I'll bring back the roadmap. So what we've done here is we've demonstrated the concept of sketched features. Sketch features are very useful. The primary task for a sketch feature is that it requires a flat surface, such as a plane or the starting plane on the screen in order to start the sketch. We cannot sketch on a curved surface. We can only sketch on a flat surface. So with sketch features, the flat surface is always required. Okay? So with that said, that is the lesson for today. I hope you enjoyed it, and we will be seeing you soon for the next lesson, which will be on place features. Thank you very much.